Today we look at simple linear regression. The question: the sales manager of Copier Sales of America, which has a large sales force throughout the United States and Canada, wants to determine whether there is a relationship between the number of sales calls made in a month and the number of copiers sold that month. The manager selects a random sample of 10 representatives and determines the number of sales calls each representative made last month and the number of copiers sold. So the data are shown on the left side. Now the question is to use Excel to plot the scatter diagram and then ask whether there is a linear relationship between the number of copiers sold in a month and the number of sales calls made last month. And secondly, to find the correlation coefficient. And thirdly, to determine at the 5% significance level whether the relationship is equal to 0 or not. And fourthly, determine the estimated regression equation. So now let's first see how to plot the scatter diagram. So to plot the scatter diagram, we can simply select all the data given on the left side and then go to Insert Charts. So you can see there are a few recommended charts, and the scatter plots are this one with the dots scattered across the figure. So we click OK. Then we have these plots. So when we got the plots, we need to check whether the x-axis and the vertical axis is really the thing that we want. So from the data here, we can see the vertical axis shows the number of copiers sold, and the horizontal axis actually shows the number of sales calls. Because we want to see whether a number of sales calls will affect the number of copiers sold, so we will put the number of copiers sold on the vertical axis, on the y-axis. So this is indeed what we want to have for the scatter diagram. So this is okay. In some other cases, if the two columns are in another way, then you may need to reverse the variables shown on this scatter diagram. So to make it look better, we can do some format. So we can add the axis title, primary horizontal axis. This is the number of sales calls, and then we delete the title. The vertical axis is actually the copier. Oops. So axis title vertical. So here I want to put number of copiers sold. Okay. So that's it. So another thing we can do for this chart is we can simply add the trend line, the linear trend line. Then this shows us whether there is a possible linear relationship or not. And also we can show the regression equation directly from this simple quick layout and this one. So we can see after I click that one, it gives us the linear relationship line and also the linear regression equation. So this actually helps us answer the question number 4. Determine the estimated regression equation. So that one is y equals to 1.184 times x plus 18.945. And as clear, the coefficient of determination is 0.5761. Now, of course, besides this method, we can go to data analysis, and then we go to regression. So input y range, y is our dependent variable. Input x is our explanatory variable. So we have label here. the confidence level, we want to choose the 5%. The confidence level is 95%. And then we put a output range. So let me choose somewhere here. Okay. So this gives us the regression output. So from this regression output, we can see the summary output in the first panel, then the ANOVA result, and then after that is our regression results. So in this regression results, the variable that matters most is this coefficient estimate. So you can see based on this coefficient estimate, we can write down the regression equation, which is y hat equals to intercept 18.95 plus 1.18 times our x, number of sales calls. Okay, so this answers my question 4. Okay, so now in question A, does it appear there is a linear relationship between the number of copies sold and the number of sales calls? So it appears that there is a linear relationship, right? So we can just simply answer yes, it appears there is a linear relationship. Now the question 2 is to find the correlation coefficient. We can use data analysis to find out this correlation coefficient very quickly by clicking here correlation. So we can have the input range. You can choose the data, then tick the label in the first row. Because our data are listed in columns, so we need to group by columns. In cases your data are grouped by rows, then you need to change the columns to the rows. Then let me give a place to report the result. So let me choose somewhere here. Then you can see the results are listed here. So the results is presented in a matrix form. And in this matrix form, the correlation coefficient with itself is always 1. So what matters is actually the number here. And from this number, we can answer the question 2. The correlation coefficient is 0.759. So after we find this correlation coefficient, it actually gives us the idea, the magnitude of the relationship. So when we answer this type of question, I will recommend you to refer to this chart here. So what we can write here is, okay, this is the correlation coefficient, 0.74059, and this actually means whether there is a strong, moderate, or weak relationship or not. And secondly, I would also like to see the keyword positive or negative. And third, don't forget that this correlation coefficient only tells you some thing about the linear relationship. So in some other cases, although there is no linear relationship, we may use other kind of lines to feed the data. So then there may be non-linear relationship. But this kind of correlation coefficient, it only tells us something about the linear relationship. So after we get the coefficient, we can say there is a positive, there is a strong positive linear relationship between these two variables. So that answers the question 2. Now question 3, to determine at the 5% significance level whether the correlation in the population is equal to 0 or not. For this question, it's a hypothesis question, hypothesis testing question, so we can always follow the 5 steps. So here I just listed the key steps. So the null hypothesis, we can put rho equal to 0, which means the correlation in the population is 0. Then the alternative hypothesis will be rho does not equal to 0. Then significance level is 5%. Then the step 3 is to use this test statistic as I have shown here. Okay. Now step 4 is to formulate the decision rule. So the decision rule is to reject the null hypothesis if this is the two-tailed test. So if the computed test statistic is bigger than the critical value, then we reject it. Okay, so we need to make the conclusion. So the first thing we need to do is to calculate the test statistic. So you can calculate T equals to R. R is the sample correlation coefficient, which is the 0.759. So I times n minus 2. The sample size here in this question is 10, as you can see here in the data. So sample size is 10. 10 minus 2 is 8. Square root over 1 minus correlation coefficient square, then square root. So this is our test statistic value. Now the next thing we need to find is the critical value. So critical value we can find from the t-table, of course. So the degree of freedom we need to look for from the t-table is n minus 2. N is 10, n minus 2 is 8. So we go to this degree of freedom of 8. Now the significance level is 5%. This is two-tailed test. So we need to refer to this part, the level of significance for two-tailed test. Alpha equals to 5%. So this column, this row, gives us the critical value 2.306. So now as you can see, since the test statistic is greater than critical T, 2.306, we should reject the H0, which means the correlation coefficient is not 0. So we answer question 3. But there is also another very quick way to answer question 3, that is to conduct the regression analysis and comes to this ANOVA analysis. From this ANOVA analysis, you can see the significance level for this F is 0.01. So we can actually simply compare this one. This is like the p-value with the significance 0.05 because it's smaller than alpha. So we reject. The reason that we can refer to this p-value is because the relationship between the F statistic and our correlation coefficient is there is some relationship. So later you can actually refer to the study guide and do some research to see what is the relationship between these two. So I will end this question here. For those of you who are interested in multiple linear regression, please move on to the next activity. Thank you.